Hey everybody, it's live app review. I'm Matt Lockyer with Near Protocol, and today we are going to take a crack at doing an end-to-end app where we're going to basically simulate like a slot machine. So we're going to use the VRF function that exists on Near Protocol. Basically, that stands for a verifiable random function. And we're not going to go into all the details about that, but we're going to use this. It's part of the environment variable in Near to generate some randomness and basically generate a random outcome for the user. So we're probably going to just like make a coin and put it in a machine and hit it and see if we win. So I'm going to start by cloning the Near boilerplate. So I'm going to clone that into a folder called slot machine in my Near apps folder. So that comes with a lot of the stuff that I need. So I'm just going to do yarn. Oops. So I probably have to go into the folder first. I'm going to do yarn and then just get rid of that log file. Get rid of that. So that installed everything I need to run an app here. Now we're going to start by editing the contract. So we need to do a lot of changes to this contract. This contract was from the very first live app review for some sort of kind of NFT thing, but it's not really relevant right now. So we're going to get rid of all of that. We're basically going to call the contract, slot machine. And again, this is going to be like, this isn't a contract tutorial. It's a very basic sort of app tutorial. So I just want to show you how to interact with this app. So we're really going to just do a really as quick as we can kind of version of a contract. I don't know if I'll even need to initialize the state and stuff, but let's leave that for now. Let's get into the methods. So what we probably want our user to be able to do is, if we want to use access keys, we do want the user to be able to make a deposit, and then the deposit will be there, and then we want them to kind of play with the deposit amount. So we can just have an access key that goes play, play, play. So what we're going to do is we'll have a payable method for depositing. And we have an amount that we're going to deposit, the deposit amount here. We're not going to return anything. We'll just keep track of some sort of credits or something. I'm probably not going to have time to do unit tests, so we'll just skip unit straight to the app test. So we'll just get rid of those. So payable, init. So what I want to do is I want to take Near tokens as a deposit, and I want to keep track of them. So all the tokens are going to come into one contract. So I have to keep track of who has what token. So I will need some storage here. So it's a good thing I left that. So let's call these credits, and let's map account ID to a balance. Do I have balance here? No. So I'm going to import that. Everything else looks okay. We'll leave owner ID. It doesn't matter. Credits. Credits. Just make sure all of that is consistent. And then after somebody deposits, we're going to have to, obviously credit them. So we're just going to say self.credits insert. Oh, we probably want to get the credits first. So get, and we usually do this okay. So I need to grab the account ID. So account ID equals and so this is the signer. I can never remember this stuff. So that's why I go to docs.rs/near-SDK and the latest version. Then I go to env. Then what I do is I get the signer account ID. So, oops, signer account ID. So that's our account ID. So now let's go get the credits at that account ID. So we have to let credits, and this is actually going to be a mutable value. Let credits mute equals self credits dot, and then I like to do, I probably get criticized by someone for this, but I like an unwrap or on numerical values, and I just assume that they are 0. So, and then just do credits deposit, and then we're just going to put that back in. So we're just going to take that and we're going to insert it. So insert, oops, insert the credits. So that is it. Probably get some sort of warning or complaint about this. I think it should be like that, maybe. No, it's fine like that. Okay, so now we want to get credits, probably. Get credits, and we will come back with a balance, and we're gonna give it the account ID that we want so that you can look up anyone's credits. Yeah, whatever. Okay. We're just going to do this one again, unwrap or, but we return it. Okay. So that's deposit. And now we just need a play method. So remember, we're just pulling on a slot machine. So it's like super, super simple. So we're going to call play. We're going to get the account ID actually, and we're going to get the, first we have to make sure they have enough credits. That's not mutable anymore. And we're just going to assert credits greater than 0. Otherwise, no credits to play. I'm going to steal a const for one near from someone else here. Just another contract, so I'm just grabbing the const there. I'm going to add it here. I'm going to call that one near. Okay, so every play is going to cost one near. Oh, whoops. That should be mutable because we're going to take the credit. So it's going to be, I think you can't do these expressions in Rust. It's super weird. I don't know. We'll try later. So we update the credits. So otherwise, if there's no credits greater than 0, no credits to play. So we update the credits, but then we have to play a round. Now, how do we know how much the contract has? We don't, but we'll just let the player win credits, and the contract doesn't have enough credits to reimburse them. That's not something we're going to tackle here. So now the big question is, where does our randomness come from? So we have a VRF in near, and I wrote a gist to basically handle dealing with the VRF in Rust. It's here. It produces a random little shout out to Mike. So it produces random function. So you just do this. So anywhere in my contract. Okay. So I think it has to be in here though. Yeah. So I want to keep this really simple. I'm just gonna have like a I don't need a big number, so I'm just gonna have a super simple, I'm just gonna have a super simple, like, out of 1 in 8 kind of chance, I guess. I'll just use the whole number. Doesn't matter. I'll just check if the number's less than something. So, we'll put that in here. We'll do, like, the probability, and we're gonna compare a 128 to a 128. I don't know. It doesn't really matter, but I'm just gonna say, what's our chance? I mean, we have to do something that we can actually see. So, oh, darn, that's actually a good point. So it has to be a small number. Otherwise, we have to make a really large number as a probability. So, yeah. I'm gonna just take this one value and return that. I'm gonna return U8. I'm just gonna make this a smaller random number. You can make it bigger if you want to. Just to make my life easier, random seed. I think you can just do this. Probably want to pass in only one of these bytes. I think that'll work. We'll see. And the probability is going to be another U8 we're going to compare it to. And we want to make sure that this unsigned, oh, darn, it's a U8 is out of 127, isn't it? Or no, it's out of 256. Whoa. Okay. Yeah, so we have to make sure that it's less than 127. So it's going to be like 0 to 255. So if we ask if it's less than 127, no, less than 128. So 0 through 127, and then including 127, and then 128 to 255. I think. No, yeah, because 256 is never counted, so that's inclusive. So 128 is your 0, going up to 255. I think that works. Yeah. Okay. So if it's less than 128, we will count it. So it's a coin flip. So maybe we want to call it flip, but actually I'll just leave it as play. Okay. So the next thing to do is basically flip it. So if like, let's just actually get the value. So let rand, so I'm so addicted to brackets. If rand is less than probability, credits equals credits plus, I don't know, you're gonna win 10. Oops. Else, okay, credits equals, well, no, nothing happens because you didn't win. Okay, then that's it. We put the credits back. So let's put them back here. So here's you winning the game or not, and then your credits go back in after you've taken one credit away. All right, so that's it for play. Then we can get the credits. These are internal, so that's it for the function. Or that's it for the contract entirely. Okay, so on to the app tests. So normally we have a bunch of app tests here under the tests folder. They had to do with the NFT contract before, but we're not going to be using that. So we're going to make an Alice account, and we're probably not going to need a Bob account to test this. We're just going to work with Alice's account here. and we're just gonna check deposit. So here we're writing app tests in jest, and we're gonna test them against our contract. Contract's probably not gonna compile though, so just hold your breath. We'll do something. We have to get a contract instance where Alice can sign it. So Alice is an account that's already made for testing with 5 near in it. So I'm actually going to change that default amount for Alice's account. I'm going to change it to be like, I don't want to run out, so I'm just going to make it 25. Okay, so Alice isn't going to deposit too much here. So she'll just do a deposit, and she's going to deposit like 5 near each time. Eventually, oh, wait. Now that makes sense. So let's do 5 here. But she needs near to pay for gas, so we'll do 6 near. Oh, but she needs enough to play, so we're gonna play in a loop. So yeah, let's go back to 20 near. Let's deposit, 19 near. We don't get anything in response to that. We don't do anything here. We don't have any arguments to call. So we're just going to deposit, and now we're going to call the contract.getDeposit or get credits, right? Get credits, and we're going to pass in Alice's account ID, and then we're going to expect. Is it expect? Yeah, expect deposit equals, oh, what are we returning here? That's not gonna work. Let's do that, because then we can expect the deposit to equal parse format. The parse near amount? No, yeah. Parse near amount. So the deposit amount should be 19 near, but in Yocto. So anyway, that should equal that. Okay, so that's the first test. Let's get rid of all these other tests. We're gonna redo all of the tests because it's a completely different app. And now we're gonna see if it'll compile, but it probably won't, so don't worry about that. I'm gonna call test deploy here, which is gonna compile the contract. Probably a faster way to test this without unit test, just by calling build.sh. So I'm gonna go ahead and, well, I think that's the first thing that gets called anyway. Yeah. Okay. So that's humming along. Let's make sure my audio is recording. I'm using a different mic. I think that's good. Okay. That took a while. Okay, so we got a couple of problems here. Assert, not a function. I know what that's about because I forgot my thing there. Random U8 is not found in this scope. Okay. That's pretty weird. It's right here. There must be a problem with it though. As U8. Problem down here. Expected. U128. Oh. I guess it was that. So that's that, and that's that. Maybe we just, oh, man. it's gonna get much more simple. I think we just need to do this. I'm gonna get rid of that function altogether and just take out 1 byte of the random seed. So here I'm just gonna get, I'll just get the 0 byte and unwrap it, and I think that's gonna be it. I might want to just make sure I cast it properly. I don't know. We shall see. Okay, so looks like it compiled. All right. So now we will see if our app works. So all we're testing right now is the deposits. We're not doing anything yet with our sort of slot machine. So typically, I mean, I would write unit tests in Rust, but I don't have time for that right now. And I mean, if I deploy this to testnet and I test it and it works against testnet, like on the live network, I mean, it should be okay. Oh yeah, I've got a contract method problem. Okay, so notice how I ran test deploy here. I'm not gonna run test deploy anymore. I'm just gonna run yarn test because I don't need to redeploy the contract. The contract compiled, it's fine. Unless I find out that I have to change the contract, I don't have to call test deploy because I don't have to redeploy the contract. So all I'm gonna do now is edit the config. It's having trouble with the contract because there should only be new, deposit, play, and get credits. Those are the only methods on the contract. So the methods were wrong. So now I'm just going to run yarn test. So you'll see it's a lot faster. I don't have to redeploy the contract. I just have to run these tests, which is awesome. Jest is still pretty slow though. Okay, so contract.purchase. Where am I calling contract.purchase? I gotta get rid of that. What folder am I in? Oh man, that's bad. I was in the progressive onboarding repo folder, so I just undid all those changes. I need to go to the slot machine folder and jump in here. And also, whoa, I changed the config. Where did I change the config? In progressive onboarding? No, I didn't change it there. I think I changed the right config. So I had some files mixed up because I went to look at that other repo. So now I'm in the config for the slot machine and it's all good. Okay. So now it should work. Sorry, the test was completely wrong. It was the old test from the near boilerplate example. Okay, so contract.deposit is not a function. Check deposit. Okay. I don't know why. Deposit, it's payable. Okay. That's really weird. Okay, hold on. Save, and the config is new deposit play. Let's double check this because I'm getting some weird stuff here. Contract methods, where are those coming from? Okay. Let's just pull those contract methods out of the config anyway, and let's try it one more time. New, deposit, play. Yeah, deposit's not a function. Okay, so let's look at the contract. So we check out these instances of these variables that it's having trouble with. So it basically says there's no method deposit on the contract, but there should be. So let's look at the contract. It says account, get credits, deposit, and then it says contract.deposit. But it is, okay, that's a promise. Got it. Okay, so that was a promise being returned, not the contract instance. So that's why it was, you could see it's wrapped in a promise here. So now we have a problem with the contract. Doesn't have enough balance, 5 near for operation costing. Okay, so I obviously edited the wrong config at some point. I went to the progressive onboarding config and I edited the wrong file, and I think I set it to 20. It should be 5 for progressive onboarding, and now for the config for this one, let's set it to 20. So it didn't have enough near. Okay, testing once again, and remember, I have not deployed the contract again. I've just been testing the front end. So okay, expected blah and got not blah. Okay, so contract get credits didn't return. Oh, promise again. Getting cornered with these promises, but that's okay. I think this will work, and then we can test the actual contract itself. So hopefully, yay. Okay, so we've deposited into the contract. So we're probably going to use this Alice contract the whole time. So we'll just do this. Excuse me. And we can just call play. Now, what do we need to call play? Nothing really. So we just call play, and then we call, oh, it's actually credits. Right? So we call credits. Okay. So now I want to write a loop. Probably gonna have to loop. Let's play like all 19 rounds. And we're gonna wait on each transaction. We're gonna await. It's probably gonna be really slow. Let's wait for 5 rounds, or let's play for 5 rounds, and then we're gonna print out the credits. And we can't expect anything because we don't know, because it's random, right? Okay. Now this is testing against testnet, which is pretty cool. So I'm just gonna say at the end of all this, because it's an async, so it's gonna await each time it goes through the loop. So I'm just gonna call expect true, and we'll see what happens. But this is the basics for a slot machine. So this is the basic building blocks. It's gonna take a little bit, or it's not gonna do anything. Doesn't have enough balance for operation. Okay. Oh. Did I use all my gas? Up. Oh. Damn. Yeah, okay. I still had a deposit on that call to the play function. Okay, and that's not even a payable function. Okay. Sorry about that. Left the deposit on there. So now we get to see how fast and easy this is. So if you really think about near, you know, it's really not that complicated. It's just, you know, go get a contract instance, deposit some funds, do some stuff. Here we're printing out our credits. So we did not win. So it went 18, 17, 16, 15, 14. So we didn't win anything. But what kind of a chance do we have to win? Well, we should have a 50% chance of winning, as far as I know. I'll tell you what. We're going to return this random value. So if we don't win, we're going to know why we didn't win. So we're going to return the, not that. We're going to return the rand value. So every time we call play, we're going to say const rand equals. And we're going to print that out as well. So now we've updated the contract. We have to call yarn test deploy. Okay. So sorry, you're gonna have to watch me figure this out. It's been a while since I've done anything like this. So I want to know what that random number is. So I'm just gonna return it from the mutable play method, and I'm just gonna watch these play tests get cycled. So 230, 90. So that should be a win. Oh, something is getting won there. Interesting. Very small amount. Now, why is that amount so small? That's pretty interesting. Okay. Oh, yeah, that's not gonna work. Maybe that. I don't know if I have to put it in brackets. I don't think so. So yeah, I wasn't paying out properly, but the random values were still pretty good. So we won a couple of times. These are like coin tosses. Okay, let's see. It's like a coin flip machine, not a slot machine. Coin flip. I'm gonna rename it. Oh, now we're paying out 10 near. Whoops. I guess that's what we wanted, right? Okay, so you can see it going down and then coming up again. So it goes, 28, 27, 26, and then back up to 35 because we spent one and then we won one. All right, cool. So now that we're done with those app tests, very comprehensive testing going on here. I'm actually going to rename it to coin flip. Okay. I think that's all good, except I'm gonna have to go coin flip. Okay, now we want to go to the app. So we want an app that we can sign in with our Near wallet and do some stuff. So we want the wallet, and we don't need the keys component. That was from Live App Review 1, some handling of keys and stuff. So we just want the Near wallet account state. We want to load that. When we load it, we've got a little loader there. So we're just getting rid of that one component. So let's boot that up and see what we got. We should just be able to like sign in with the Near wallet. Just gonna zoom in a bit. Local keys. Yeah, I bet you're complaining about that. There it is. Okay, so we're already signed in, but we're gonna sign out, sign back in. I'm gonna zoom in for you. Okay, si1.testnet is my usual testnet account. I don't know why. So I have a balance and I'm all signed in, and that's thanks to the, whoa, don't want to do anything there. I don't know what's going on. Whoa, I got some weird TypeScript invasion here. Whoa. I think I know what happened. I have got an imposter. I am going to get out of this. I've got some really weird file stuff happening, so I'm going to close that. Open again. And, oh man. Just going to have to close all. Oh, I think it was from renaming that stuff. That was a no-no. Okay. I think it's all closed now. So back into coin flip. And start. Okay. So we're already signed in. We got our balance. So that was thanks to the wallet component. It's already done. It's already loaded. I'm signed in. So I'm going to make another, actually, no, I have a component here that handles the contract. So the contract component, we're not going to use the local key stuff. We're just going to set, what we'll do is we'll set some local state for credits. That's what's going to be displayed on the screen. We'll load the credits when we first get in. We'll just do that every time. Contract, get contract. No access key account. We're just going to create it with the account. So we're going to assume we're signed in. If we're not signed in, account should be null. So if no account, return. So this component will just sort of self-hide itself. Just get rid of it. We are going to update credits. So I'm going to make this like a general purpose method for updating credits. I'm going to go contract, get credits. And again, we can assume we have the account here. Okay, and I don't think I need to use, I'm not going to try catch or do any of that. Okay, just set credits. We need to await that. Await. Okay. I don't know about this get contract. Export function get contract. Nope. Doesn't return a promise. Okay. Update credits. Here what we're going to do is we're going to handle play. And we are going to call gas. Oh man, we're going to need to make a deposit too, aren't we? Okay. So remember, we're not going to do withdrawals or anything. We don't have time. So we're just going to handle the deposit and handle the play. So get contract, contract dot deposit. So we're going to take in an amount. I'll do an amount here for the contract interaction, set amount. We're going to basically go and we're just going to no arguments here. Parse near amount, the amount, and that is going to be nothing there. So we will just call update credits when we're done. Handle deposit, handle play. So after we play a round, we're going to want to also update credits. So we'll make buttons for all of this stuff. Just double checking everything. Set credits to get credits. Nope, we don't need to do that. We need to play. So let's steal that from here. There's no deposit on playing. We're just going to call contract.play. And we are going to get rid of all this. We're going to get rid of all this. We're going to get rid of all this. Whoa. Okay. I'm going to save something. So I'm going to buy credits. Credits. So it's credits in near. amount is the amount, and set amount is the target value there, and then handle deposit is gonna be buy credits. This will be a heading for everything, so I'm just gonna say like play, come play. Okay, and then let's do a double break there, and we'll just say that this button is going to play. Okay, or like it's a coin flip, so you know, flip, fun. Okay, blah blah blah. Looks good to me. Let's run it. All right, I want to change the order of these. Actually, I want to put the wallet at the top. Okay. Oh yeah, oh yeah. You got trouble, don't you? Missing field account ID. Come on. What a pain in the... all right. There we go. So we're all good. So how many credits do we have? Oh, let's print out our credits. Play, and then we're gonna put current credits. All right. Let's see what happens. Current credit 0. So we're gonna buy some credits. So I'm gonna buy 10 credits. Buy credits. Cannot read property. Blah. Oh, okay. Handle deposit is expecting an amount. We can get away with not expecting that amount. Oh. It's in our local state of the component. So buy credits. Okay, requesting the transfer of 10 near. Sounds good. Let's do it. Let's play. Let's get lucky. Okay. Credits looks awful. So we are going to format near amount. So that's good that that was conveniently waiting there for me. To 2 decimals? No. I'm going to format it to 0 decimals. Getting tired here. All right. And now we're going to flip. So here's the thing. We probably want to do something where we keep track of all of our flips. So flips, set flips. So we'll just push stuff onto this flips array. Okay. So we will play, and then, oh, this is going to be tough. So how do we know we won? We could take the response from the contract because we get the value and we know that it has to be less than 128. So we'll just say outcome, and then if outcome is greater, less than 128, flips dot push true. Oh, actually, this is even better. Okay. So now we can keep track of our flips. So basically what we'll do is we'll say flips.map the flip outcome, and then we'll just put you know, if it's true, then we'll just say you know, here, we'll put it in a p tag. We'll just say 1. And if not, we'll just put it in a p tag. We'll say lost. Okay. So flip credits 10, flip. Lost. Each child should have a unique key prop. Don't you hate React? Come on, man. This is... I don't like looking at it any more than you do. Okay. Are you satisfied? Now this is local state, so we won't know. We're gonna erase that, but we're down 1 credit, so we know we lost. We're gonna flip, lost again, flip, lost again, flip. 1. Whoa, look, we got 16 credits. Wow. Good thing we can withdraw them. Wink, we can't. So that contract basically ate up 10 near, gave me credits, and basically I'm rolling with imaginary money now because I can never get the near tokens out of the contract. So I highly advise you to finish this example, but so that you don't lose like I'm losing right now. And basically finish it up on your own. So you're going to need to add a withdraw function. And you're also going to need to make sure that the payout will not be more than the contract can afford. So that's another key, but I'm really losing. I have no idea how I'm losing so much. Okay, I won again. I better win some more. There we go. It is kind of fun, I gotta be honest. It's kind of cool. Okay, I'm winning a lot now. And I lost again. Okay, so the point is that now this contract only has 10 near inside of it, but it's telling this player that they have won 45 near. So in addition to creating a withdraw function where the user can actually withdraw from the contract the amount of near that they're currently showing in credits, you also have to protect against the contract being able to show a user more credits than the contract actually can pay out. So that's difficult. So I'll let you do the moon math and you check in with me. But that was live app review. I hope you enjoyed that one. It was kind of cool. We made a coin flip app in like 45 minutes, something like that, probably longer. So yeah, once again, Matt from Near Protocol, we just made a Rust smart contract for a coin flip, and you can find us at near.ai/docs. You can also join our Discord at near.chat and get a nice friendly invite there. Come join, check us out. We're hacking at ETH Denver, so you can find out more about what we're doing under the community tab. And then everything you need to get started is right here. I also have a playlist on the Near Protocol website called Live App Review. So we are doing the series here where we're covering all of these app topics. So yeah, check us out. Near.chat, join the Discord, and near.ai/docs. Also look for this. It's episode, well, you would know that because you already got here. This has been episode 7 of Live App Review. It's a coin flip app. Cool.